The broadcast is now starting. All attendees are in listen-only mode.
Good evening, everyone. Thank you for joining us. We will start in a couple of minutes. Thank you. Okay, so let's start this webinar. This is the episode number 4 of your Personal Trainer series. It's a series for, let's say, focus on customers, but also for all the other curious. Here with me is Alessandro Tornincasa. Let's go on. We are using actually GoToWebinar platform, so you can input your question as soon as you have, and it's suggested because in the meanwhile we can answer to your questions, or we will be ready for do so at the end of the webinar. As usual, the webinar has been recorded, so you will receive a link to review the webinar in a couple of days. Let's review also the entire installments. So we started in June with SOLIDWORKS simulation, with tips and tricks, also with flow simulation, and a special episode focus on research and development tools within our platform. So today we will explore better the design to manufacturing approach. Again, I'm Alessandro Bellini. I'm the Senior Territory Technical Manager for Euromed. Euromed means Balkans, Israel, Italy, and Turkey as well. And I'm the simulation specialist over this territory. Here with me is Alessandro Tornincasa, that is the TTM for Balkans and is the specialist for technical documentation and visualization. Alessandro, are you connected?
Yes, good morning and welcome to everybody.
Okay. So it's your turn. Let's go on with the model-based engineering.
Yes, model-based engineering is a novel approach for product development and in general for product lifecycle management. It means that an electronic model will drive not only design but also manufacturing and other activities like inspection and procurement. These processes can this way exchange data and improve in time, and therefore the time to go from idea to the final manufactured product is compressed. I will be showing an example of one of our testimonials called Urban626 that developed a fantastic product called URB-E. It's a vehicle for urban mobility. It was showcased at CES in Las Vegas in 2017, and you see some images from the news. This vehicle is very light, can even be stored in a car, very cheap, and also it can run as long as 15 miles. You can customize it with many accessories like this basket for shopping or supports for your phone. You can even bring it in public transportation, and you can remove the battery and can plug in your phone charger or your computer. So as you see, there are some amazing features, and this product is manufactured in Pasadena in California in USA. So as you see, this product had very strict requirements. It had to be electric, affordable, lightweight, long range, easy to fold, and the battery should have been removed. The amazing thing is of this product that was shown at the last SOLIDWORKS World is that it was developed in a very short time, just 6 months, by using practically almost all of our product portfolio. We were amazed by this short time, so we decided to collaborate with Urban 626 to build a roadshow that took place in the United States last summer, and we told the story of a process from design to manufacturing using their data. And today we will do a short version of it. So first, we will be showing how to do project and data management, how to create a concept in SOLIDWORKS, virtual prototyping, that is an important phase of the process, how to present the product, and this is the phase in which you accelerate your idea. Then there's MBD, which accelerates production. So the next phase will be creating technical documentation for the product, and manufacturing, which can either be subtractive or additive, and of course quality control will be an important part of this process. So these are all the phases in which you're actually making the idea. Let's start with the project and data stream management. If you have such a short time to manufacture your idea, you need to have a tool that will allow you to subdivide the project in phases, allocate resources and hours budget, and also a way to allocate, to create some activities and assign them to people. So in this case, you see the list of all the phases and the milestones. In this case, the biggest milestone was the CES show. SOLIDWORKS Manage will allow you to do all of this and give you at every time a clear view of the situation. And this is a view of the activities for one of the phases and the person that is involved and the status of that activity. So SOLIDWORKS Manage was important for Urban 626 because it allowed to organize and drive the activities to meet to meet the plan in such a short time. By breaking up the project instead, you can keep the team aligned with the priorities and you're sure you reach your milestones. Project management is just one aspect of SOLIDWORKS Manage. Our colleague Marco Esposito is doing some webinars on it. There are other capabilities like item management, reports, or advanced BOM creation. This is a tool that can go on top of your current product management solution, and it's very powerful, and everybody in the company can use it instead of Excel spreadsheets. Another important aspect of accelerating design to manufacturing is having something that accelerates information and helps communication, and this is PDM. With PDM, everybody in the company can access very many kinds of data like CAD models, simulation results, documents, and also you have ability to track the evolution of your design. So this is a plastic part, you see from the start how it looked, and then all the modifications that were made to it. You can also automate processes, for example, an approval process. So when the part is approved, an approver will review it, and once it's approved by the reviewer, some actions will automatically be started, like exporting to STEP, 3D PDF, or DWG, and it's very easy to set this up. So once the document is released, a previously set up folder will be used to store all the files for manufacturing, and you'll be sure that the manufacturing will get the latest version of the part and won't manufacture the wrong version. So with PDM, you are safe because you're saving your data on a secure vault, and also you have ability to grant access based on the role, and so you can prevent accidental deletion or modification of the file. you're always working on the latest version of the file, and you have access to revisions to track the project evolution. And tasks can automate the data flow to manufacturing. So once a file is released, imagine a file with MBD annotations, it's ready to go to production, and it eliminates errors because you're sure it's the right version. So next phase is the conceptual design. You can, for example, Urban 626 created a concept of the mechanism of a closing mechanism by drawing blocks in SOLIDWORks. It is very quick to create this layout, and if you want, you can even use SOLIDWORks motion to study the kinematics or the dynamics of these mechanisms. Once you've validated the first concept, you can create a more refined concepts using block and rerun the simulation. And this same data can be used to create the final shape, because you can extrude or take as reference these blocks to build all the other parts. So you've seen using SOLIDWORks and SOLIDWORks motion. Its sketching environment is intuitive by definition, and it accelerates the ideas development because it's very easy. In this case, motion was used to optimize the folding mechanism. Maybe I can ask Alessandro an opinion about using motion in this phase of the concept. What do you think, Alessandro?
Yeah, I think it's the very, let's say, focused use of SOLIDWORks motion, because basically you are in the beginning of the process and you can do a lot of changes. You can try a lot of shapes, and it's very easy. Also, you can leverage those sketches later to modeling to create the final model. So it's very important to do so.
Very good. Okay, next phase is virtual prototyping. So it's the subject of Alessandro, so I'll let him explain you.
Yeah, we saw with this kind of example that not only we are sketching an idea, but we are trying that idea. We are analyzing that idea immediately with a virtual prototyping. So basically we can leverage also now the 3D phase. So from 2D sketch, we are leveraging the model, and now we are facing some requirements. For example, we want to test if that kind of the design with 3 wheels will be, let's say, stable over a curve, so with a constant acceleration and with a speed of 15, 16 miles per hour. So the vehicle must stay top, but in this case, we can see with motion again, this is the dynamic approach. It's not just a rendering or just an animation, it's a dynamic analysis. We can see that on the curve, it's not stable, basically. And we didn't produce any prototype at all. Of course, we can have some results to check better the situation, and we can find out that the velocity there is about 8 miles per hour. So it's unstable at that kind of point. So what we can do, of course, we are in the very first stage of the design. We can change the design, and what they did, and they replaced the 2 wheel bars with just 1 wheel. So more like, let's say, a motor scooter. So it's very easy and very fast to evaluate the concept. We are reducing the prototyping cost because basically we are just using CPU calculation time. And we have developed the full product in a very short time. So after that, it comes the structural part of the simulation, the virtual prototyping. So URB has leveraged this kind of situation to analyze this component, this bracket, and here is let's say the system with some brake force and an axial force. So basically they started analysis with the aluminum 6061, and they had in mind to reach at least a factor of safety of 2. So having that said, let's view it in a simulation very quickly. Some fixture, so those points, some forces, very easy to apply. And there is another one on the bottom, let's say the axial support. And in a couple of seconds, we can see all the results that matters. So in this case, we can see the stresses, we can see the displacement in inches, for example, and also we can see the factor of safety that in the minimum point is 1.4. So we are not achieving the factor of safety that we need. In order to do that, it's very simple now. So URB designers have changed the material to AESI 4130. So it's an alloy steel. And now in a couple of seconds more, just updating the analysis, they could reach a minimum of 2.3 as a factor of safety. So the factor of safety is now, it's good. The component is behaving like it's intended. And they avoid at all to produce any prototype. Just to summarize, simulation structural analysis, it's very easy to use. It's helped them to take decision from the beginning, and of course to reduce number of physical prototypes. So it's a virtual prototyping workflows. Just to review the final stage, they had built a final prototype, and this is the test that they had, the fatigue analysis and structural analysis, and this is the real behavior that is very similar to the simulation behavior they performed. So last step, but not less important. So basically also from engineering point of view, they had performed an analysis to understand the battery cap manufacturability. So this is the cap that is, let's say, over the battery, and of course it's a plastic injected. So here we have also some tolerances to check, and the strength, because it has to be connected to the battery in a very precise way, and then also it has to sustain some loads. So the factor of safety there is needed is 3. So let's start from plastics. So this is SOLIDWORKS plastics, and it's very simple to see the feeling. In this case, we can just leverage the 3D model to see if it's injectable, and of course the timing, and if we can have some problems, and we can, let's say, take in decision to have a better design. Also, they had with Plastics Premium, they had also the displacement results, the warpage results. So they've been analyzing the effect of the thermal displacement after the mold release. In this case, of course, they had some problems, and they changed the design. So this is the way effective to avoid completely to produce a prototype and to see immediately what's going on. From strength point of view, there are some situations that you would analyze, that would assess, like the shocks while driving. So in this case, that part, the first version was having a factor of safety of 2.1, so it was not intended to use for that kind of usage. So with many virtual tests that they had, either in structural simulation and in plastics, they could achieve the optimal design with a 52% of increase in factor of safety and a 9.3 decrease in the warpage of the plastic part. So they basically researched and developed a full product, a full part here in a unified environment with full associativity from the analysis and the model. And of course, they, let's say, at the end, they passed the physical test and the quality controls.
Thank you, Alessandro. That was amazing. Okay, now we talk about presentation of the product. Presentation means creating a photorealistic image of your model without actually manufacturing it. In this case, we are talking about this plastic part that covers the wheel. Rendering is not just for marketing. There are also some very important applications, because it's needed to give the idea of the final appearance of the product before manufacturing. So if you need to take a decision of the appearance, the color of material, you don't need to manufacture your product, but you can do it with virtual rendering. So you can choose your material, your color, your finish, and it can also help you with manufacturing. So without having the mold maker to create a prototype, you can immediately advise him on the finish you want, and you avoid him to create many prototypes and just get to the final prototype. So you can communicate also the desired quality. So the product that will be used for the rendering is SOLIDWORKS Visualize. I remind you that SOLIDWORKS Visualize standard is included in all SOLIDWORKS Professional and SOLIDWORKS Premium licenses with subscription. This is a very easy use environment to use. You can include very realistic effects like depth of field, and if you are using, and you can include the materials from the library, which have very, very realistic effects. And as you see, the finishing of this material looks really very, very real. If you have Visualize Professional, you can even create configurations, so you can prepare all the versions with the different colors and materials you want. And when you're finished, you can launch a render queue so that after some minutes, you get all your pictures rendered. And also I want to remind you that Visualize is very powerful because it leverages the GPU, so it's a very fast render. And if you have Visualize Professional, you can even build your render files by leveraging Visualize Boost. These are the final pictures of a proposal that were given to take the final decision on the material finish. And also there were considered some alternatives with different colors or different materials. Another application of Visualize is, of course, marketing. You can even create interactive HTML files that you can rotate, or you can create very, very realistic animations that will engage customer. So Visualize, as you've seen, is very easy, fun to use. So the realism of the output will help you to take decision on your design, on manufacturing, and you can also create consumer experiences. But Urban 66 had to also accelerate the time to market. So they decided to set up an e-commerce site, and they use SOLIDWORKS Sell. It's a new product that will allow you to publish a configurable model, for example, for e-commerce. So you can start in SOLIDWORKS by defining which are the parts that you'll configure for what concerns the shape, or for what concerns the color or the material. So here I'm selecting some parts that will be changed. Once you're finished and you publish your model, it's published to the cloud, but actually it will publish only a mesh, so your intellectual property is protected. When you publish the model, you can access a portal from any device, any operating system, and you can start configuring your model. So for the configurable part, you can access a library of materials and finishes. And then you can create an HTML, and one use case is just an HTML for internal design review to take decisions on materials, because you see this is also a render. It's very, very realistic. If, of course, you change a component, you can just republish, and all the 3D models on our portal will be updated. This is the final application, which is the e-commerce portal. You can actually go to the Urban 66 site and configure your URB. So you can change the colors, add the accessories, rotate the model. As you see, it's a very real render. And when you're finished, you can even buy it. So you see, SOLIDWORKS Sell is simple to do the upload, because you do it from SOLIDWORKS, and we are not taking your intellectual property because we're working with mesh. You can use any device, so any person can create the content. And by creating these experiences for your customer, you can distinguish from competition. Next phase is SOLIDWORKS model-based definition, which is key to accelerating manufacturing. Definition of model-based definition by ASME is an annotated model and its associated data elements that define a product in a manner that can be used effectively without a drawing graphical sheet. We will see why. This is model-based definition, so it will allow you to smart dimension your model by choosing your datums, and all the manufacturing features will be completely defined with all the required dimensions. And also it will show you the status of the tolerances by giving you green, completely defined features, yellow, not completely defined. But you don't actually need to define everything because, for example, those pockets don't need a very tight tolerance, so you can insert a general note and insert a general tolerance surface profile for this model, and it will be okay. The annotated model must be presented in a way that it's easy to read from people in the manufacturing or quality. So you can create 3D views which organize those annotations like in a 2D orthogonal projection. So you create some projection where you see only annotations visible in that projection. And after that, you can directly send this model to manufacturing. But let's see why it's a model-based definition helped URBAN 626. The first thing is that it reduces errors, because there are many studies like the NIST studies that showed that there are many cost savings. They did a benchmark in which 3 models were sent to some manufacturers that base their processes on 2D drawings, and some manufacturers that base their processes on 3D models. And then they measured the time to manufacture and inspect the model. For all these models, it turns out that the model with 3D annotation took 70% less time to be delivered and manufactured. So there is a big time saving. The time saving is actually in manufacturing and inspection, because modern processes can leverage information from the PMI and be automatic to create the parts program or the CMM program. Another aspect that was considered is the delivery time. The model-based models took only 5 weeks, while the drawing-based manufacturing tools 32 weeks to deliver the parts. Why? Because there were many clarification requests, and those clarifications stopped production, and there were big delays. Another problem was with quality. One part was scrapped because there was an unintended through hole. This is because on the 2D drawing that was created, the designer forgot to indicate the depth and didn't add an extra section view to show the whole depth. While this didn't happen for the model-based processes, because the manufacturer could rotate and take a measurement on the 3D model. But this is quite clear, because if I'm showing you this drawing, it could be either this part or this part. We would need another view for more clarification. Imagine how difficult it is to interpret this drawing, very complicated, so it's very likely that there will be errors. While if the same part is made with model-based definition, you can leverage on GD&T, put very few annotations and define it completely, and you can also leverage the automated part programming process. Of course, URBAN 626 didn't do a drawing like this, but they directly defined the annotations on the 3D model and used them for production. Also, you could argue that there are some manufacturers that don't have CAD. Well, you can even create 3D PDFs from model-based definition. So you can send out a PDF like this, where you can click on annotation, and the relative feature will be highlighted, or you can see, for example, the datum reference frame or the datums associated to a tolerance. And you can, of course, see also notes. You can also attach to the PDF a novel format called step 242, which brings over the geometry, but also those 3D annotations. So even if you have a CAM that can read those in annotations, it can automate part programming. Next is the time. Urban 626 experienced a time reduction thanks to the process automations. You have to consider that 1/3 of the money spent on a project is spent on creating, but also maintaining drawings. That's a very big cost. And also, most of them don't match the 3D models, because when you're sending to a manufacturer a 2D drawing, what it does actually is redrawing the model in 3D just to understand how it should manufacture certain features, and by doing interpretation errors, the final manufactured model doesn't anyway correspond to the drawing. Maintaining a lot of paperwork is a cost. For example, the United States Department of Defense estimated that the paperwork to document a tank is much more heavy than the tank itself. And also there are some emergent 3D technologies like simulation, CAM, rendering, inspection that leverage information from the 3D model. If you're still based on 2D drawings, you'll never be able to accelerate because the drawing will be a bottleneck. And also you have to consider that there is a domino effect. For example, in Germany, there is an initiative Industrie 4.0. There's Made in China to 2025 that are giving some incentives to digital and smart manufacturing. And if you're working with the Department of Defense and you're part of the supply chain, sooner or later you will be required to provide model-based documentation, and the same applies for General Electric or for some, or if you're working with the Japanese industry. Some big companies like General Electric have already done this in practice. There's this General Electric Brilliant Factory initiatives where actually the factory is completely automated. So all the machines can take information from the process to improve it or to do preventative maintenance. They also implemented additive manufacturing and big data, because if you need to collect such a big amount of information, you need to be able to handle it. And of course, the automation is based on the manufacturing, and the quality is based on model-based processes. Okay, next is the technical documentation. If you want to deliver the URB, you will need to give an instruction manual. So we'll talk about Composer. Composer is a tool that can be used by a person that doesn't know anything about 3D CAD, can be the documentation specialist. So they can open a model that is still associative with SOLIDWORKS, and they can create very easily exploded views with lines and, for example, with annotations like arrows to clarify the operation to be performed, insert pictures to show the tool that will be used to disassemble these screws, and also they can publish raster or vector images for the final documentation. And you get a documentation like this with high quality, very easy to understand. You can reduce the text that is required, and this will save you a lot of money. Another application of Urban 626 was the interactive documentation, and they're using it for spare parts. For example, one customer will send over the picture of the part, and the person in charge of spare parts will have to understand what is the part that is required. So you can just access an interactive HTML document and identify the part, and from that identify the interpreter code for manufacturing purposes. And then you can send an email for confirmation to the customer to confirm the order of the part. Another issue could be that one part is changed, for example, this component, the shock absorber, and generally you will need to redo all documentation. Not in this case, because you can launch an update command that will synchronize the Composer model to the SOLIDWORKS model, and all the views that you saved will be updated, and so will do the pictures in the documentation. So you've seen that Composer will improve quality of your documentation. You will reduce time because you'll be able to create documentation in parallel with design. And also you can reduce errors and improve efficiency in processes like spare parts, or even there are some application in assembling. So you're creating specific assembly instruction to avoid error mistakes when assembly, or to train new people more effectively. Okay, next will be the subtractive manufacturing. So I'll switch over to Alessandro.
Okay, thank you. So we are seeing now something about CAM, so SOLIDWORKS CAM. We will analyze this bracket for the let's say the battery accessory. And okay, let's go on. And we see that in a moment with SOLIDWORKS CAM, we are able to extract all the features that are machinable. So it's a technology based on feature recognition. And SOLIDWORKS CAM, it's applying strategies to those features. So you can see facing, roughing, contouring, and refining all these kind of features. And also remember that SOLIDWORKS CAM standard is it's integrated in SOLIDWORKS, and it's included in each station of SOLIDWORKS with Subtractive subscription. Also, we can leverage all the information within the simulation of the toolpaths. Here, it's an example. Also, it's very interesting. Let's go on. Okay. It's very interesting, of course, to generate all the NC program, and in SOLIDWORKS CAM we have, let's say, all the standard post-processor for the FANUC, for example, or the Adenine, and so on. Also, another thing that is very interesting, let's say, within the MBD process is the fact to leverage all the information from MBD, and in this case, the tolerances, to create and to perform the strategies to cut this particular hole, for example. So we can run the tolerance-based machining, and we are able to recognize not only the feature, but also the tolerance that is attached to. And in this case, for a normal tolerances, we have just a center and a hole. Now, if we change the tolerance to a stricter tolerance, now automatically the strategy is to add a bore feature, because we have to achieve a much better precision. And again, if we are restricting to, again, the tolerances, now the bore is changed to a rim feature to have a very fine precision on the hole itself. So that is the tolerance-based machining inside SOLIDWORKS CAM standard. And now we can see also the program itself running on a CNC machine. So here we can see benefits, for example, capturing the best practices, because from the very start, SOLIDWORKS CAM is proposing us strategies to cut the features, but then we can also immediately change those strategies, and they will be used the next part. Also, we are eliminating errors, because we are not relying on drawings. We are not checking any 2D views. We are using directly the 3D to produce the CNC machines. And of course, we are speeding up the manufacturing process because of that.
Okay, thank you, Alessandro. Also, I would like to remind you to have a look at the handout panel, the documents panel. From there are some documents that you can download. For example, a white paper about design to manufacturing solutions, and some specific information about some of the products that we are showing. Okay, next will be quality control. You know that quality control is a very tedious task, because you need to take a 2D drawings, choose the characteristics to be inspected and balloon them. And then you have to create an Excel spreadsheet with all the list of characteristics, their nominal value, tolerance, maximum min value. And this process takes a lot of time. We've improved and helped the work of quality inspectors by releasing SOLIDWORKS inspection for 2D drawings. But I wanted to show you in the application for Urban 626, we're even more accelerating the process because we're doing inspection reports from the 3D model. So you can run the inspection report creation, and the SOLIDWORKS inspection will balloon the MBD dimensions directly. And in few seconds, you are ready to go out with the report. So imagine how quick it is to create a quality control plan for Urban 626. I wanted to show you another interesting application. It's not from us, it's from our partner, Origin International, and the software is called Checkmate. It can read the MBD annotations, and from that, it will create the program for the CMM machine, and finally will produce a paper report or a graphical report showing the zones that are out of tolerance. This is the software in action. I remind you, it's not a SOLIDWORKS software, it's a partner software called Checkmate for SOLIDWORKS. This is the list of this is the program that was automatically created and the characteristics to be inspected. And you can run a simulation to check for interferences on your part. And when you're finished, the program will be sent out to the CMM, which will actually inspect the part. And this is the SOLIDWORKS board recording what you at the stand of Checkmate. By eliminating repetitive tasks, so SOLIDWORKS inspection can help to reduce the errors, of course, and it can compress time to create these inspection reports. So now we're going to the other stage, which is additive manufacturing, because today there are many companies that are starting to leverage on these processes. This is an interesting application by Urban 626. They decided to implement an accessory, which is a Furby, that is a smart accessory because it incorporates a PCB with the Android operating system, so it can, and also a GPS, so you can command it with voice controls. You can ask for it to navigate, and also there is a speaker that will tell you the direction to follow and the turns. The eyes can blink when there's low battery, and you can touch the ears and use it as a turning signal, and the relative eye will blink. This part will be produced by additive manufacturing, and it is not a mathematical model. So the model that was used by Urban 626 was downloaded, purchased from a site that offers this service. So in SOLIDWORKS, what was imported is this model that is a mesh. You don't need to rebuild the mathematical model from the mesh. You can just keep working with the mesh. All we need to do in this case will be creating the internal space for the PCB. So we just create a normal extrude, and after that, you can convert the solid to a mesh. And when it's a mesh, you can do a subtraction between the two meshes, and this way you can leave the space for the PCB, and then you can split maybe the case. So as you see, SOLIDWORKS supports also a modern manufacturing process like additive manufacturing. The next phase will be creating the PCB. In this case, what will be needed is a collaboration between the electronics designer and the mechanical designer, and it must be done as quickly as possible. This can be achieved with SOLIDWORKS PCB. So once the design is finished, you can use a messaging system internal to SOLIDWORKS and PCB to communicate the intent. So the PCB designer will place the components, let's say, in a way that it doesn't have much logic. So it can send this data to the mechanical designer. It will become 3D parts, and the mechanical designer can proceed and move the parts at their correct locations. And then the PCB designer finally can see what was the shift of the part to check if there are any issues with the electronic design. So as you see, this way there's real collaboration, and you can efficiently design these connected devices. So we'll ask for the help of Alessandro, who will tell you a very innovative process for additive.
Yeah, exactly. In this case, also was let's say the focus was to use the mesh on the base to start from that a support, to build a support. But in this case, of course, we want to leverage those kind of hands or let's say foot of the Furby. And this kind of things is not so easy to model inside SOLIDWORKS, but let's see what's happened with the topology optimization, because we use this approach, of course, to have a lightweight design, also stiffness, and of course we have some geometrical constraints to build. So in this case, with the topology optimization within SOLIDWORKS Simulation Professional and Premium, we leverage the geometry, the initial geometry. In this case, with the use of the wrap function and a sketch, a specific sketch that are the foot of the Furby, the footprints, we used that for splitting the surfaces and to use them as a constraint for the topology study. We can see in a moment. So we input the fixture there, and on the base the load, that is the Furby weight. And in this case, the final results of the topology study is to optimize the mesh and to find out which is the correct path to follow to have enough strength. And in this case, the mesh itself, it's ready to be produced as an additive manufacturing. So we are talking about 3D printing. So you can see in very few steps, in very few minutes from the idea, we go to the printable shape in very, very short time.
Thank you. That's amazing. It's a very complex shape, and it's amazing how short time it could be created.
Yeah,
really
exactly.
Impressive. Okay, so next I want to talk to you about a partnership that we've done with 3D Systems. We are offering a software to all SOLIDWORKS customers in subscription that is called 3D Expert for SOLIDWORKS. It's made by 3D System, but it can use also other brands of 3D printers. So you can directly send your model from SOLIDWORKS to the 3D printer without converting it to STL. And here you can optimize the part orientation, you can create supports, you can create surface lattices. And also there is an advanced version, but if you pay an extra fee, that will do advanced lattice structures or advanced simulation. If you don't have a 3D printer, that's not a problem, because we are offering the service to print the part, which is called 3D Experience Marketplace Make. So you just upload your part, it will check for errors and repair them. Then you can choose the manufacturing process that can be traditional or either additive, and the list of available manufacturers will be shown. You can ask for a quote to a supplier, and the supplier will reply after some minutes with the quote. Once you have accepted the quote, you can use our secure payment system that is as much secure as Amazon for the payment. And then when you send the order, the part will be finally manufactured with the additive process. And then it will be delivered in time, just like Amazon. So we want to really call this the Amazon of manufacturing. Okay, so now I will launch some polls. So I'll kindly ask you to answer. So what was the level of interest for this SOLIDWORKS webinar? Okay, thank you. I'll close the poll. and then I'll share it with you. Thank you for the positive feedback. Next poll is for those that were interested, of course. If you would like to be contacted for further information on our smart manufacturing ecosystem. Okay, I close the poll. Thank you very much, and I'll show it to you. Thank you for the good feedback. And then one last question, just to help us to focus our next webinars. So what aspect of the product development process was more interesting for you? Okay, thank you very much. I'll close the poll and show you the results. Okay, thank you very much for your feedback on virtual prototyping, Alessandro's field, and the technical documentation, which is my field. And I also see a big interest in additive and subtractive manufacturing. So we will focus our future webinars also on that, maybe in 2019. So I'll remind you of the next episode. In mid-December, we'll talk about mechatronics, so how to integrate your mechanical design with the electronic design, which we already saw in part today, and how to integrate it with the electrical design. Also, there is an initiative for 2019 that we have thought about, so I'll ask Alessandro to comment on it.
Yeah, we thought about, let's say, giving and receiving something. So if you send us your simulation, we can get you some advice. We can, let's say, suggest improvement and for the from productivity point of view and the results point of view. In exchange, of course, based on, let's say, signing a waiver, we can show this the most interesting case in your personal trainer series 2019. So we are thinking this kind of help only for current simulation portfolio. So basically customers that are under subscription. And of course, it's not meant to be a consulting activity. So this is an idea for 2019. We are waiting for your let's say, contribution in this case.
Okay, so there is some room for the questions. So please feel free to ask any question about these processes that you've seen.
As usual, the webinar has been recorded, so you will receive the link in a couple of days, so you can review all the information on the recording itself.
Okay, I see one question, which is where can I download the 3D Expert for SOLIDWORKS? You just go to customer portal and you access the usual section where you can download the service pack, and there you will find the 3D Expert for so you will find the link to access 3D Expert for SOLIDWORKS, which will bring you to a page on 3D system, and also you'll find a link to download the 3D Experience Marketplace app, which you can use inside SOLIDWORKS to request your quote. Okay, I think that we are just about in time. I don't see any more questions, so thank you for the attendance, and thank Alessandro for co-presenting.
Thank you, Alessandro.
We will see you in December then.
Okay, bye-bye.
Bye. Bye-bye.